So initial test run for motors. We used to test run every motor. We have some customers that require us to do it on incoming. Today we're more selective. If it's a 2-pole, or if it's a customer that says, I want it done, or if you call and you say, I have a vibration problem or a particular problem, then it's really important to do an incoming test run. Beyond that, we will wait to do the run afterwards. But on that, we gather a lot of good information. We do the test run, gathering the nameplate, doing the IR to ground, phase-to-phase resistance, if it passes that, checking some other things like bearing insulation, end-bell insulation, measuring it. On higher voltage machines, you'll have end bells or bearings that are insulated to protect it from circulating current, that kind of thing. So doing the test, this particular page of the test, we're documenting vibration and temperatures and the temperature equalization that might occur as you do the test run, or stabilization. Final test run, same thing, we're repeating it, and we test all motors on final, obviously. This is a additional data sheet for sleeve bearing motors, where we're documenting a sleeve bearing motor, a ball bearing motor, the motor's fixed axially as far as you being to physically move the shaft. Sleeve bearing motor has what we call end float, and there's mechanical clearance that is allowed for it to flow. So we're measuring what we call extend and retract. We're measuring the shaft voltage, measuring right on the shaft to the frame on the other side of the insulation. What is the voltage that we're measuring? As crazy as that sounds, you want a voltage measurement. The lower that value is means the insulation is not good. And again, the voltage values are low. We're not talking machine rated voltage values. We're talking anywhere from less than a volt up to maybe 5 volts AC, DC, depending on the mix. Vertical form, getting critical information on a vertical even before you dismantle the runouts, and getting that information on final. So talking about why is full nameplate voltage important. During test runs, applying full voltage ensures that we're magnetizing the unit properly. And what's more important about that is motors will have problems. They're going to have uneven air gap. They're going to have frame distortion issues. They're just going to have these different things that don't show up unless you go to full voltage when you do the test. So doing that test and then taking a vibration analysis. If you do vibration analysis at reduced voltage, you're not getting the right picture. You're getting a much reduced version where you would think that the motor's okay and it's actually not. So really important to do full voltage testing.